I'm Joseph Junke, and this is my second MP, and I have to talk very close to this microphone so you can all hear me. I am working, those of you who know me know that every year I come with a different company, and this year I'm working with C4UC, the Center for Understanding Change, and our task is to take these models. If you haven't heard about this, 3 years ago, John Veller talked about these amazing SIPDIS or models created by DHS that predict the future effectively. And it's a cascade effect. So if there's an influenza breakout in Tennessee, that affects coal production, which then affects steel production, which then affects automotive manufacturing. That's the idea. My job is actually to make, and I think my job's harder, by the way. My job is actually to make it so that human beings can actually consume the results of this data, to see what it means, and in many ways really start to talk about how we actually get and make decisions through these concepts. So what you see here is on the right is actually one of our models. It's very complex, and that's actually one of the simple ones. It's for a healthcare model, and it's what happens if something good or bad happens to healthcare. It has to go through all those arrows, and somewhere it comes out, and we all die. So, you know, it's a scary thing, right? It's serious. So one of the techniques that I actually apply is the creation of metaphors to help humans kind of consume data. We like to bring them in forms that you can actually understand because you've seen it before. It's called natural user interface or humane design. You heard that earlier this week. And so we're actually looking at a really interesting concept right now. This is the mountain path. And what's interesting about this is if you look at the mountain path, you consider the fact that the path is actually, I am here, I want to go there, and I don't want to fall off the mountain. So it's a familiar metaphor, we get it, and it's something that we can kind of visualize pretty easily. What's extra exciting about that is we're also visualizing, if you think about the path as actually plotted data, we're visualizing travel, slope, the impact if you happen to slip off that path, in other words, the rate of change or the force of gravity. We can visualize wind. You know, are there other impacting forces that are impacting this particular metaphor? Texture. So as you look at these slides and you see, you know, the rocky surface, maybe that's something that's a little less certain. You know, it's an uncertain path versus a certain path. Points in time, multiple points in time. These little workers can be considered points in time. So for those of you that are the seasoned data experts, this is an XY chart. It has two components. One is X, which is time, and Y, which is any variable we care about right now. Let's say GDP. I'm going to give you an example using this that can help see the work that we've done, kind of walking down this path to explore this visual metaphor. So if you rotate this thing slightly in a 3D matrix, and you put brothers and sisters next to it, you start to see data in a comparative manner. This is exciting because the one in the middle that's actually riding along the x-axis is our original data set, and the ones that are next to it are actually modulations of that data caused by a decision. The decision could be I shipped 5,000 gallons of water, or the Fed changed the interest rate by 0.01%. It could be anything, really. If you rotate that again and look straight down the x-axis, you see the trend lines are actually showing that we do have slope. We have these subtly declining, you know, pastoral impacts for our change, which is kind of nice, but not always the case. It's not also always symmetrical. In this case, a move to the right, let's see, which way are you guys facing? A move to the right is a dramatic decrease, and a move to the left is a dramatic increase. So that's nice, but that's not the hard part. The hard part is that we need to get more data in there because, you know, having a simple, you know, Excel-generated chart isn't really going to solve our problem. So we just added some extra lines and turned it back on its x-axis, and now you're seeing a cross-section, a temporal cross-section. And you can see now that, again, we have slope. We have, if you had one direction, we have diverging variables, and in another direction we have similar or asynchronous variables, which could be, you know, an important deciding factor. On top of that, we actually have to show obscurity or confidence. So we widen it as far as we get. So our goal right now is to make 12 of these, 12 paths that we can view simultaneously. And we've made work, looking at visualizations, generating these beautiful 3D models, falling off mountains. That was my thing. But I'm standing here now with a humble request, and that is research is being done. Nobody here is an expert at what we're about to encounter. While we have to do 12, we're actually going to do 100, and then we're going to do 1,000. And when we get that kind of data consumption happening, nobody's done that. It's really a hard problem. So I'm coming to you and I'm saying, hey, let's talk about this. Has anybody seen this before? Has anybody experienced with this? Has anybody got some really cool models we can mess with or data we can pump through our CIPTIS models, or the models the Center for Understanding Change? Because at the end of the day, this is what I want to build. I want to build a spatialized version. If you guys remember, my first presentation was all about augmented reality. And it's going to do this. Thank you.